Hey curious kids, Kevin here. Today's video is a little bit different. It's a special one. I've gone through my videos over the last couple years and I've put together a little highlight reel of my favorite ones. I hope you enjoy. What's up guys, Kevin J. DeBruin here, former NASA rocket scientist.
This is Kevin DeBruin. He's an aerospace engineer at NASA's Jet Propulsion Laboratory.
I designed spaceships that are looking for aliens, specifically Europa.
Here to discuss is Kevin DeBruin, former NASA systems engineer and CuriosityStream in-house science expert. Welcome to the show.
What's up everybody? So my name's Kevin. I'm a former NASA rocket scientist. So I spent a few years designing those spaceships that travel to other planets. And then I fell in love with educating people about space and science, so now that's what I do. I am CuriosityStream's brand ambassador for all things space and science. There are over 5,000 crayons. Oh my God, it's working! I confess I did it wrong. Oh no! Oh, we're doing the Macarena? It only takes 3 minutes to get to Mars. Hey curious kids, Kevin here. Today on A Place Called Space, we are going to talk about how long it takes to get to Mars. Earth and Mars both orbit the sun, but Earth is going around faster than Mars, so they aren't always on the same side. Being on the same side of the sun together is called being at opposition. The way I remember that word is because they're close together, like two opponents facing off. Mars and Earth line up at opposition every 26 months. So we have to wait for that to happen to launch, because we don't want to launch when we're far away. And since we can't travel at light speed and they're both moving around the sun, we need to plan. So it's like throwing a football, right? We have to throw or launch our rover where Mars will be so that they get to the same point at the same time together, like a wide receiver catching a football pass. Look out here. So this is lava flow fields. So it's cooled lava, so it's basalt. And we see that same thing on the moon. So what's really important is for astronauts, right? So the Apollo 14 astronauts came here and trained in 1969 to prepare for their moon landing, because the basalt rock here is very similar to what we see on the moon. And now you're wondering, well, what about Mars, maybe? Yes, so Mars also has lava flow fields that are kind of like this. So we have teams of scientists and engineers that come here and test the rover's equipment and some of the instruments. Now, we found a gas. So gas, you've heard of things like solids that are hard, liquids like water, and then gas, like air. We found phosphine in the clouds. Now, why is this so exciting? Well, here on Earth, we find phosphine when it's associated with or like linked to tiny little bacterias that they don't need oxygen to survive. And they give off this phosphine. So when we're finding phosphine at Venus, it could mean we're finding something alive that's given off this phosphine. And when I found out about the King of Random, I'm like, all right, if there was a caveman building a Mars rover, because we got one going there right now, how would we build the drill? My heart rate is going down to about 66, 65. It's up there a little bit. Maybe I'm a little nervous because I got to compete against this athlete over here. So we're making a Grace-sized crayon as we melted everything. So let's start down low, Grace. Let's talk about this. So these layers look bad.
Special.
You can see there's like
Cracks.
Cavitation, multiple different colors. Especially these two are apricot melted into our brown because it was just too hot.
Here, this
started to learn.
Yes. Well, this brown was an issue in itself because it cooled the fastest out of any of these other colors.
This is like the perfect visual learning curve you could see. It's like, oh no, 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 no.
Oh, you're learning. You got it. Oh.
I'm a professional who needs more lessons. Ah! Yeah!